Hello, welcome to Earth. Look, you are here, right where that little compass is stuck on, North America. And what gives us day and night and warmth and seasons? The sun, right there. So, it's pretty much how it is in space, right? What goes around the other? Does the Earth go around the sun? Does the sun go around the Earth? Well, hopefully, after Galileo and Copernicus and all of the people who studied the heavens have convinced the general public that the Earth is what travels around the sun, you have been taught as much and believe it. Maybe you know that there's something wrong with how the Earth is sitting on its axis here. Our Earth does not stand straight up and down from the top and the bottom. It's tilted at about 23.5 degrees so that when it travels around the sun, it's kind of sideways, just a little bit. So you might know that when the Earth is tipped towards the sun, that's when we have summertime. When the Earth is tipped away from the sun on our side of the northern hemisphere, that's when we have wintertime. You see how the bottom half of the globe is pointing at the sun right there? And the top half is pointing away? Well, some people think that the reason that it's summertime in the southern hemisphere right now is because it's closer to the sun. Have you ever toasted a marshmallow and seen that the bottom of the marshmallow got brown before the marshmallow that was a little further up the stick? I want you to remember that, because even though the marshmallow is about the same distance from the fire, the part that collects the most heat is the part that turns brown first. And it's almost like our Earth is soaking up the rays to get a tan, and that is what is causing the seasons more than how close it is to the sun. But there's something else I want to show you here. If that's the sun and that's the Earth, there's nothing there showing us that they're different sizes. And I just want to make sure that you realize that the sun is enormous and that the Earth in comparison is puny small. So I'm going to make the sunshine bigger with this balloon. The balloon can show that the sun is huge, but it's not going to show how heavy it is or how hot it is. So this sunshine's getting, fired. You're fired, sunshine. There you go. And the new sunshine's coming in. So this is a little bit bigger. This is closer to scale of how big the sunshine would be. So do you think the Earth can stay that size, or do you think that it maybe is too big, too small? Your thoughts? Well, it's actually super ginormous compared to what it's supposed to be. If we had the Earth to scale, it would be this big. Can you tell what that is? That's a little peppercorn. It's a tiny seed. Compared to the balloon, here we go. It's that big. Oh no, the Earth just got swallowed up by the sun. Okay, so there's the peppercorn. That's the size of the Earth compared to a scale proportion of the sun. But we're nowhere near that close. We're way, way, way out in space. So in order to show you that, I need to go outside, because you're familiar with what a yard is? A yardstick? There's like 1 foot. If we put the peppercorn at 12 inches and the balloon back here at 1 inch, 0, that is still enough to have us incinerated. We would not survive being that close to the sun. But if we put the Earth where it belongs, to scale, in space, this tiny little peppercorn, it would be so far away from the sun, we could probably not even see it. And that's why we have to go outside, because the room we're in right now, almost guaranteed, is not big enough to show you how far away the Earth actually is from the sun. So hang on, time out, we'll go outside and show you how far away that actually is. So get ready to figure out the scale and distance between the Earth and the Sun. Okay, this is my backyard, just in case you were wondering, and that's my cat. Here's a little peppercorn, and all the way over by the fence, that's more than 2 first downs away for football fans, is the balloon that represents the sun. So we're a long way away for something that is so small that if I dropped it, I probably couldn't find it very well in the grass. So welcome to Earth. Let's find out what makes seasons. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 paces representing 93 million miles. All right, let's get to work on figuring out how to position these two really poor examples of actual space in a way that helps us understand the relationship between how the Earth is pointed at the sun and what season it is.